Welcome to 5-4. Here's where we can actually start doing integrals without having to come up with geometric stuff, without having to use the left and right rectangular approximation methods, which is also called the Riemann sums. So this is where we get to have some more fun. Yes! The fundamental theorem of calculus states that the integral from a to b of f of x is the antiderivative of b minus the antiderivative of a. Now the other thing here that I usually get asked is the plus c is something that I'm not really going to worry about, because if I do f of b plus c for the antiderivative, right, minus f of a plus c, what happens to those c's? Well, same function, so the c's will subtract and make 0. So we're not going to worry about the plus c's or the original solution, because those constants will just subtract anyway, so those aren't going to be super important for this stuff. But essentially, to calculate the area under the curve, it is f of b minus f of a, as long as we are talking about f of x as the antiderivative of f. So this should be pretty straightforward, so it's just going to be a matter of practicing this stuff. I'm only going to do the day 1 notes in this video, because day 2 involves the average value theorem, the mean value theorem, the second fundamental theorem of calculus, so there's a lot to it. So I want you to just focus on this day 1 stuff, get this down, and then we'll go into the next part. Okay, so evaluate each definite integral, definite because it has a value. So first, what I want to do is the notation here is I want to take the antiderivative, so x squared over 2 plus 2x from 1 to 3 is how that notation will look. That bar just means I'm going to evaluate it as f of 3 minus f of 1. Trying to think if there's anything else I need to tell you. That's really pretty much it. Right, so then this would equal 3 squared over 2 plus 2 times 3 minus 1 squared over 2 plus 2 times 1. And you could actually leave your answer like that, right, if it's a free response question, but if we have multiple choice, we need to simplify this a little bit. So I would have 9/4 plus 6 minus, the second one would be 1/2 plus 2 would be 5 over 2. And 5 over 2 is 10 over 4. So this is equal to negative 1/4 plus 6. So 23/4. All right. So that would be your answer. And the other nice thing about this stuff is you can check this stuff really, really easily in your calculator. So in your calculator, let me pull it up. X plus 2, 1 to 3. Let me do this. Block some of that light. All right, so what you can do is I pulled up my shortcuts, but under math, so if I go to math, you have FN, functions, numeric derivative, or integral, and my calculator looks super nice. Yours may or may not look like this, but it's from 1 to 3 of x plus 2, I believe, for d of x, and it comes out of 8. Did I write something wrong? 1 to 3. Cool, I totally did something wrong. That's wonderful. Oh. Okay. Yeah. Boo, this 2 is not squared. So boo, that should be 2. So boo, 9 over 2 minus 5 over 2 would be 4 over 2. So this is 6 plus 2 is 8. I'm so sorry. Good thing we checked our answer, right? Yay. Okay, so that's how you can check your answer for all of these moving forward. It'll make it super easy for you, especially as you get into the calculator portions of the test. When you take the AP test and my tests, you're not using your calculator on the no calculator. Punks. All right. So again, I'm going to find my antiderivative first. So let's see, that would be 2/3, so it would be x to the 3/2. So 2/3, so 2, yep, from 1 to 4. So this would be 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. Let's see, 4 to the 3/2. I would do 4, the square root of 4 is 2, and then raised to the third power is 8, so 2 times 8 is 16, minus 2 should be 14. I'll verify my calculator. It is. Alrighty. The antiderivative of secant squared is tangent, so this is the same thing as tangent from 0 to pi over 4. If you're going to check this one on your calculator, make sure you're in radians, as always in calculus. So this is tangent of pi over 4 minus tangent of 0, which would be 1. Alright, I would rewrite this integral first before I do this. So -1 to 3 of 2t minus t squared dt. So the antiderivative would be t squared minus t cubed over 3 from -1 to 3. So I would have 9 minus, well, that'd be 3 to the third over 3, so that would just be 3 squared. So 9 minus 9 minus 1 plus 1/3. Yeah. 9 minus 9 is 0, and then we have -4/3. I'm going to verify that one because there was a lot of math that I did in my head. -4/3 it is. Big money. Okay. Antiderivative 2x plus sine of x from 0 to pi. So I have 2 pi plus sine of pi, which is 0, minus 0 plus sine of 0, which is 0. So 2 pi it is. Pretty confident in that one. All right. Haha, how ugly does this look? But really, it's super easy. Because by your Pythagorean identities, you can either change the top into tangent squared plus 1 or the denominator into secant squared. Makes no difference, right? But this is using your Pythagorean identities to make this essentially the integral from 0 to pi over 4 of 1, which is x from 0 to pi over 4, which is pi over 4 minus 0, so pi over 4 it is. Okay, so that's really all that today is going to be talking about. It's just seeing how to use the first fundamental theorem of calculus. There is another one that we will get into in a little bit. But your homework is just going to be a bunch of practice of this stuff. As always, any questions you guys have, let me know, and I will talk to you all soon.